When factoring, there are a few special products that if we can recognize them, it can really help us factor polynomials. We are going to go through some in this video. The first is difference of squares. So something in the form of a squared minus b squared can be written as a plus b times a minus b. In this case, a and b are terms. Because this is just a factored form, we can multiply this out to check. This gives us a squared minus ab plus ba or ab minus b squared. As you can see, these middle terms cancel out, and we're left with a squared minus b squared. So, for this one, we have 49x squared minus 4y squared. As you can see, these two are both squares. This one is a square of 7x, and this one is a square of 2y. So, it's a difference of two squares, so we can factor this as 7x plus 2y and 7x minus 2y. When I see a difference of squares problem, my first step is to find what a is and find what b is, and then it's easier to write out the factored form. Next, we have sum of squares. In this case, the rule is that a squared plus b squared is always prime and can't be factored. And the reason for this can be explained with an example. So, let's say we have x squared plus 4 here, and we're going to do factoring by the AC method. We're looking for something like x plus p times x plus q. And we expect this to equal to x squared plus 4. So, this gives us x squared plus qx plus px plus pq. So we have x squared plus q plus p x plus pq. We're looking for two numbers where p plus q is equal to 0 because there's 0x up here, and p times q is equal to 4. So let's look at the factors for p and q. We have 1, 4, and 2, and 2. It could also be two negative numbers, so let's write those as well. And now let's see whether any of them sum to 0. 5, 4, -5, -4. As you can see, none of them sum to 0, so it can't be factored. And the reason for this is because when we have the sum of squares, this number will always be positive, which means you have two positive numbers or two negative numbers. And if you add up two positive numbers, it won't get to 0. And if you add up two negative numbers, it also won't get up to 0. And for that reason, the sum of squares, a squared plus b squared, will always be prime. Now we have the perfect square. This is saying that if we have something that looks like a squared plus 2ab plus b squared, this is equal to a plus b squared. And if we have a squared minus 2ab plus b squared, this is equal to a minus b squared. Because this is just a factored form, we can multiply and see why we get 2ab. So here we have a squared plus ab plus ba, which is the same as ab, plus b squared. As you can see, this gives us a squared plus 2ab plus b squared. The reason we can just do 2 times ab is because we're multiplying the same polynomial twice, so we'll get ab plus ab in the middle. On this side, we have a is equal to x, b is equal to 4, and we have that the 2ab is equal to 2 times x times 4, which is equal to 8x. So we know that this is x plus 4 squared. And on the right side, we have a squared minus 2ab plus b squared equals a minus b squared. This is very similar, except there's a negative instead of a positive. We multiply this out. We get squared minus b times negative ba, which is the same as b, and plus b squared, because two negatives make it positive. So we get a squared minus 2ab plus b squared. Like I said, because we're subtracting ab twice, we're simplifying it to negative 2ab. And here we have very similar stuff. So a is x as before, b is 4, and here we have a negative. So the negative 2ab is equal to negative 2 times 4, which is equal to negative 8x. So we know that this one is x minus 4 squared. Now, let's get started with sum of cubes. This says that a cubed plus b cubed equals a plus b multiplied by a squared minus ab plus b squared. As you can see, we have three signs here that we need to remember, so there's an acronym for that, known as SOAP. S stands for same, O stands for opposite, A stands for always positive. And this is in relation to this sign right here. So in this case, we have a plus. So here, our first sign is S, which means the same. There's a plus here, so we have a plus right here. The next sign is O, our opposite. Because this is a plus, we have a minus right here. And lastly, we have this sign right here, AP, always positive. So this one's always positive. Now, we can get started with our example. We have x cubed plus 125. 125 happens to be 5 cubed. So we can rewrite this as x cubed plus 5 cubed. That way, it's easier for us to factor. Now, let's get started. We have a plus b, so that's x plus 5. And then we have a squared, which is x squared. We have minus a times b, which is 5x. And we add b squared. b is 5, this is 25. And when you factor it, you should check your signs. So here we have S, O, A, P. So same, plus, plus, opposite, plus, minus, and always positive is plus. Now we have difference of cubes. So we have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. This is similar to sum of cubes, except some of the signs are different. So this is where knowing SOAP really helps. So for here, we have S, O, A, P. As you can see, now the sign here is negative, so same means this is a negative, opposite means this is a positive, and always positive means that this one right here is always a plus. Now we can do the same thing. So 8 is 2 cubed, so this is actually x cubed minus 2 cubed. Now we can factor out our equation. This gives us x minus 2, x squared plus 2x plus 4. So now let's check our signs again. We have S, O, A, P. So same sign, so negative, negative. Opposite means negative, positive. And always positive means this is always a plus. This is a combined review of all the formulas that we've covered so far in this video. Just as a review, the difference of squares states that a squared minus b squared equals a plus b times a minus b. The sum of squares, a squared plus b squared is prime, this means that once you see something as the sum of squares, you know that can't be factored anymore. For a perfect square, a squared plus 2ab plus b squared equals a plus b squared. And for the subtraction one, the only difference is that there's a negative sign right here instead of a positive sign. For difference of cubes, they're also quite similar. As you can see, all the terms are the same, only the signs are different. And that's when you remember SOAP. Same, opposite, always positive. Same, opposite, always positive. Next, we're going to go through different practice problems. Let's get started with some practice problems. So let's start with x cubed minus 27. The fact that x is cubed makes me wonder whether this will be the difference of cubes. So 27 is 3 cubed, so it is. Let's rewrite this as x cubed minus 3 to the third power. Now, it's easier for us to tell the a and b. So a is x and b is 3. So we know to factor this, it's x minus 3, x squared, plus 3x plus 9. Because we know that S, O, A, P. So same, opposite, and always positive. What about for this one? We have x squared minus 4x plus 4. Since this x is x squared, it's a square, and this 4 is 2 squared, it makes me wonder whether it's a perfect square trinomial. So, to do that, let's find what 2ab is. Assuming that a is x and b is 2, 2ab is 2 times x times 2, which is 4x. And here we see that this could be a negative 2ab, which means that this one is x minus 2 squared. For the top right, we have 27 y cubed plus 343. Because I see a cubed here, I'm trying to see if this could be the sum of cubes. In this case, 27 is 3 cubed, and 343 is 7 cubed. So let's rewrite this as the sum of cubes. So this becomes 3y cubed plus 7 cubed. So we know that a equals 3y and b equals 7. So this is factored. 3y plus 7, 9y squared minus 21y plus 49. So we get SOAP, S-O-A-P for the signs. Same, opposite, always positive. That should be correct. And lastly, we have 25 times x squared plus 100y squared. Let's start by factoring out this 25. This becomes 25 x squared plus 4y squared. Now, is there anything else we can do? X squared, that's a square, and 4y squared could be written as 2y squared. So here we have the sum of squares. So we know that this is prime. So this becomes our final factorization. Here we have 72n squared minus 200. Let's start by grouping out an 8, a common factor. This gives us 9n squared minus 25. And here we have the difference of squares. So a is going to be equal to 3n and b is equal to 5. So this gives us 8 times 3n plus 5 times 3n minus 5. For here, we have 18n a squared plus 8b squared. Let's take out a common factor, a 2. This gives us 9a squared plus 4b squared. This gives us the sum of squares, where a is equal to 3a and b is equal to 2b. Because this is the sum of squares, 9a squared plus 4b squared is prime. So this is our final factorization. What about this one? We have 4b squared plus 4b plus 1. So 4b is 2b squared, and 1 is 1 squared. So let's check whether this is a perfect square trinomial. So a is equal to 2b, and b is equal to 1. So 2ab would be equal to 2 times 2b times 1, which is equal to 4b. In this case, we do have 4b right there. So this means that we have 2b plus 1 squared. And what about this one? We have x cubed plus 216. Because there's a cubed here, let's check whether 216 is the cube of anything. In this case, it is. X cubed is 216. So we can rewrite this as x cubed plus 6 cubed, which means that a x and b 6. So this gives us x plus 6 and x squared minus 6x plus 36. And let's check our signs. We have S, O, A, P. So plus plus is same, plus minus is opposite, and this one's always positive. Now we have a squared plus 12a plus 36. Let's see. A squared is a perfect square, and 36 is also a perfect square. Let's check whether this matches. So in this case, a is equal to a, and b is equal to 6. So 2ab is equal to 2 times a times 6, which is 12a. That matches. So this is a squared plus 2ab plus b squared, which means this is a plus 6 squared. Now for this one, we have 16 x to the 4th power minus 81. This looks like the difference of squares. In this case, a is equal to 4x squared, and b is equal to 9. So, knowing that, we know that we can simplify this to 4x squared plus 9 and 4x squared minus 9. But are we done? If you look at this side, 4x squared plus 9, that is the sum of two squares. So we know we're done on this side. The 4x squared minus 9 here, this is a difference of two squares, which means we can factor again. In this case, a is now 2x and b is 3 based on this one. So this one is for this, and this one is for this one. So this means that fully factored out, we just copy the original one down. This becomes 2x plus 3 times 2x minus 3. And now we're done factoring this one. Here we have 8x cubed minus 125. 8x cubed is 2x to the 3rd power, and 125 is 5 to the 3rd power. We have the difference of cubes here. So a is 2x, and b is equal to 5. So this gives us 2x minus 5 times 4 squared plus 10x plus 25. And let's check our signs. S, O, P, P. So same. So negative, negative. Opposite. So this should be a positive. And always positive. So this is plus. And lastly, we have k squared minus 36. This is a square. And 36 is also a square. So this is the difference of squares. In this case, a is equal to k and b is equal to 6. So we know this factored is k plus 6 multiplied by k minus 6. We've reached our challenge question. Pause and see if you can get the factored form of this expression. Now, let's get started. We have 3x to the 4th minus 243. Let's start by grouping a 3 out. This gives us 3 times x to the 4th minus 81. Now, this looks like the difference of squares. So let's start with a being equal to x squared and b being equal to 9. So this gives us 3 times x squared plus 9 and x squared minus 9. So we have x squared plus 9 here, which is the sum of the squares. So we know that this part is done being factored. But if you look at here, we have x squared minus 9, which is another difference of squares. This goes here. And here we have a is equal to x and b is equal to 3. So this factored gives us x plus 3 times x minus 3. Our final answer is 3 times x squared plus 9 times x plus 3 times x minus 3. And that's the end of this video. Thank you so much for watching.